Hello again, and welcome to Haybridge Maths Department, Year 2 Pure, where we're looking at Chapter 3 on series, and today we're looking at 3.6 sigma notation. And this funny Greek letter here is a capital sigma, and we're going to be using it today. So let's get started. Okay, so this capital sigma, not to be confused with a lowercase sigma. When it's a capital sigma, we use it in mathematics to tell people to add up. But it's a signal for you to add up if you see the sigma. It's different to the lowercase sigma, which we use in statistics, and we use that for a population standard deviation. Here we use sigma, and it means to add up. You might have seen it on Edexcel, where they have a button with a sigma on it, and that tells you to add up like a row or a column or something. So here we have some weird mathematical notation. We've got some weird mathematical notation with this sigma involved. Now, if we have a look at the bottom of that sigma, you'll see there's a little r equals 1. And on the top, there's an r equals, well, there is just a 5. Now, what this is telling us to do, so it's an instruction. It is saying, take r equals 1 and put it into 2r plus 1. So sub it in. And if you were to sub in 1 into 2r plus 1, then you get 3. What we have to do now is sub in 2. So you get 5. And then you have to sub in 3, so you'll get 7. Sub in 4, and you get 9. Sub in 5, and you get 11. And what the sigma is telling you to do is to add these values up. So sigma tells us to add up those values. So that is like an instruction, a set of instructions on what to do. So whenever you see that. Right, let's have a look at a different example here. So it's my go. I'm going to go through this. I want you not to forget to make notes, pause to make the notes, and then listen and just watch while I'm speaking. Pause to make the notes. So for this, I'm just going to show you. It's going to be very much like what we just had before. So you've got r equals 1 to 5 for 2r minus 1. And if we do that, if you put 1 in, this time you get 1. Put 2 in, you get 3, then 5, then 7, and then 9. Adding those all up, you get 25. Okay, that's straightforward enough, I hope. What I'd like you to do, pause, as we said, make notes, and then have a go at this question here. Right, if you had a go at that, then you should have got something that looked like this. It's going from 1 to 5 again. It doesn't have to be 1 to 5. We'll have a look at some different numbers in a bit, but we're starting at 1. We put in 1 into 3r minus 1, so you get 2, and then you get 5, and you get 8, and you get 11, and finally you get 14, which is equal to 40. Okay, reasonably straightforward enough. As I say previously, if you've got that right, give yourself a big tick. Okay, let's have a look at a different, slightly more complicated example now. Okay, the thing to notice about this example, first of all, we have 2 to the power of r. So when we sub in values of r, we're going to raise 2 to the power of those values of r. The second thing to note is that we're not starting at 1. We're starting at 5 this time. We're starting here, if you can see, we're starting at 5 and we're going through to 7. So on this example, what we're going to do, is get rid of that there. What we're going to do is we're going to do 5 times 2 to the 5, add on 5 times 2 to the 6, add on 5 times 2 to the 7, which if you plug that all into your calculator, you should get 1,120. Okay, pause, make the notes, and then have a go at this example. Right, so on this one, we're starting on 4 and we're going through to 6. So if we sub in 4 first of all, so you get 4 times 3 to the 4 plus 4 times 3 to the 5 plus 4 times 3 to the 6, which apparently, if you plug that into your calculator, you get 4,212. Okay, so hopefully it's some weird notation, but it's quite standard or quite straightforward once you get your head around the notation. Talking of standard, there's a nice link there. We're going to have a look at a couple of standard results now. So let's have a look at a couple results to do with sigma notation that you should just know. And that is, the first result is if you add up 1 n times, you get, unsurprisingly, n. Let's just show you very quickly where that comes from. So if you've got sigma r equals 1 to n of 1, that means do 1 plus 1 plus 1 plus 1, add an ellipsis, plus 1, and you're doing that n amounts. So if you've got n lots of 1, hey, you've just got n. So it's useful to have that result when working on things. Let's have a look at another standard result, which it's good to know just straight off without having to work anything out. Okay, this one's slightly more complicated. If we start at r is 1 and we sub in 1, when we do 2, 3, 4, all the way up to n, then if you add all those up, then you get this result, which is n over n plus 1, all divided by 2. So if we do r equals 1 through to n of r, you get 1 plus 2 plus 3 all the way through to n. This, of course, is for triangular numbers. Well, the answers are going to be the triangular numbers, because if you were to arrange, if you had, I don't know, like snake balls, like you have with a triangle there, then this forms the number of balls in the triangle. So like if you have 1 row, you only have 1. If you have 2 rows, you have 3. If you have 3 rows, you have 6, 10, 15, like that. Now, what we can do, what you need to know, is that if you add all those up, if you add the 2 n's like we did previously on the it was arithmetic one, then if you do the 1 plus the n, you get n plus 1, and you're going to get n over 2, lots of n plus 1, which you can write as n plus 1 over 2. I've kind of gone very quickly over where that comes from. It's something you might want to have a little play with, see if you can work out where that has come from with a little bit of a hint that I've given you there, but I wouldn't dwell on it too long. Let's now look at an example from the textbook. I'm going to do it differently to the textbook because the textbook doesn't use the standard results, even though we're going to do those here. Okay, so we're going to do the this example, and we're going to use the standard results. So what we can also do is, like we can with integration, is that we can split this up into two. We can split that up into two different summations, two different sums. So this is between r is 1 and 20, and r is 1 and 20. So you've got those two there. We can also do, I mean, that doesn't look much like r equals 1. You can also, like you do with integration, you could move a constant like this 4 outside over here. So you can get 4 the sum of 4 lots of the sum of, so 4 times the sum of r between 1 and 20, and then we add on that r is 1, the r is 20, and we're doing 1. Now we can just employ what we had previously from the standard result. So we will do, here we'll do 4 times, and it's n over 2 times n plus 1, which is going to be 20 times 21 over 2 plus n, which is 20, which is going to be 860. Okay, so what I would like you to do now is make the notes if you haven't done so already. So pause this and make notes as we go through. Just make sure, I'm just trying to move this up for you so that you can make notes, go through that, and then have a go at this example here. Right, now on this one, we go back to the pen. We needed to do this as 5 lots of a sum between 1 and 10 of r plus 1 between 1 and 10. So it's the sum of those two. So you've now got 5 times 10 times 11, because it's n times n plus 1 over 2 plus 10, which is 285. Okay, hopefully you got that right. Those examples, I hope, are relatively straightforward. Let's have a look at something a little bit weirder, and then we'll get you guys working on an exercise. So can you have a look at this example here? It's 2 parts to this example. We've got part A and a part B. Let's have a look at part A, and then let's look at how we can use part A to solve part B. Right, in part A, we have to do the sum between k's 1 and 12. We've replaced r with k, not a problem. And then we've got 5 times 3 to the k minus 1. We can bring that 5 outside because it's just a constant. We've got k equals 1 and 12 of 3k minus 1. I'm just going to move the equals over here. It's something I'm not keen on doing, but I need to write out this series in a bit more detail. So we've got the 5 outside, and now we're going to stick the numbers into the summation here. So when k is 1, we get k, take away 1, so it's 0, so 3 to the 0. plus 3 to the 1 plus 3 to the 2 all the way up to 3 to the 11. And what we have here is a geometric series. We have a geometric series where a equals 3 to the 0, which is 1. R equals 3, because we're timesing by 3 each time to get each number in the bracket. And we've got n equals 12. Now, using our knowledge of geometric series that we've done previously, we can add up what's in the bracket, some of the first n terms. So you have a 3 to the 0 times r to the n, 3 to the 12 minus 1 over r minus 1, close the bracket, plunk that all into your calculator, and apparently you get 1,328,600. Okay, bit weird, but nothing too peculiar. What we want to have a go at now is part B. In part B, we want to add up the same series, but this time going between 5 and 12. And the way that we are going to do this is that we're going to say going between 5 and 12, well, that's like doing between 1 and 12, but then taking away 1 to 4. So you've got this 1 to 12. If we imagine that you have a number line, here's, well, 1 to 12, we're going to add up. But if you go to, well, 1 to 4, if that's 4, then if we get rid of this, then if we're only dealing with whole numbers, that's the problem with doing it in a number line, is that there's gaps between the numbers. But what's left here is the 5 to 12. Not the best explanation, if I do say so myself, but hopefully you understand my tactic with what I'm going to do here. So we're going to add up between k's 1 and 12 of 5 times 3 to the k minus 1, and we're going to take away the bit going up to 4. So it just leaves us with the 5 to 12. Okay, so we've already done the bit here, this bit here, we've done that already. And if you remember, we've got 1,328,600. So now we just have to take away, we can take the 5 outside, and we've got 3 to the 0 plus 3, 1, 3, 2, 3 cubed. And do you know what? You could do that as a geometric series if you wanted to, or if you can do like what I did, which is just put it into your calculator. So you end up with 1,328,600 minus 200, which is going to be 1,328,400. There you go. So, little bit weird, but hopefully you understand the concept now that you can use one series, take away from the other, and that will complete the gap for you. What I'd like you to do now is something similar. Oh, of course, I want you to pause, first of all, make notes from here without any way of getting feedback from you. I don't know if it's doing this that actually helps you. But make notes on that, then have a go at this question, which is quite similar. Okay, let's have a look at this one. Now, first of all, we are going to work out, I haven't broken this down into two parts. You needed to make sure that you break it down into two parts. Let's do the part A bit of it. Let's work out r equals 1 to 100. So if we work out r equals 1 to 100, or 3 times a half to the naught, a half to the r, we can take that 3 outside, and you've got 0.5 plus 0.5 squared, 0.5 cubed plus dot dot dot, there's your ellipsis, plus 0.5 to 100, and close the brackets. Once more, it's a geometric series. This time I'm going to use the other version of the formula because we've got an r that is between -1 and 1. So we've got 3 times, and we've got 0.5 brackets 1 minus 0.5 to the 100 over 1 minus 0.5, and if you work all that out, you get 3. Then, if we work out this between 1 and 4, and you've got 3 times 0.5, yeah, maybe in the background you can hear a toddler playing about, and sorry about that if you can. Then you've got 3 times 0.5 plus 0.5 squared plus 0.5 cubed plus 0.5 to the 4. Work that out, and you get 3 lots of 15 over 16, which is 45 over 16. So to finish off with, to work the two bits out, you needed to do r equals 5 to 100, 3 times 0.5 to the r, and here you're going to get the 3, you're going to take away the 3 times 15 over 16, which if you take out a factor of 3 and then do a whole take away 15 over 16, you're going to get 3/16. And there we are. We are done with that. Hopefully you got 3/16. Well done if you did. Go back and correct if you didn't. Now what I'd like you to have a go at is the next exercise, which is exercise 3F. Thank you very much.